Okay, in this video, we're going to go through the process of graphing one of these polar curves we've been talking about. And what I'm going to do is I'm going to show you what it's going to look like on a TI-84 and how we could go about getting a table of values to help us plot. Now, we could always plug in the theta values for theta and try to use some unit circle intuition to help us get the R values and to plot the curve. And my table's pretty large here. I tried to, for every grid line there is on this polar grid, I have a theta value for it, so that way we can fill in the table and we can plot. And if I wanted to look and see how this would work on my TI-84 calculator, now again, this is an app that I have here on the iPad. It is very similar to the keystrokes that you would use on the TI-84. It does have some differences, but it's pretty close. Now, if I wanted to graph a polar curve, I need to make sure my calculator is in polar mode. So I press the mode button, and I'd look and make sure that the y variable is set to polar. And it currently is. And I also want to make sure that the angle is given in radians, and which it is as well. And so the radians matches the angle measures that I'm going to use to graph this polar curve because they're all in radians. Now, I would go to y equals, and I would type in my polar curve. Now notice that all the functions are written as r equals, and that's the way it's supposed to be. So I start typing in 4 cosine of 4 theta. Don't hunt for the theta button on the calculator. It's the same input button you use if you're in function mode for x. And then I'll go, before you press graph for polar functions, kind of like if you're also working with parametric, we want to set a good window. And I need to set my theta min and my theta max. 0 to 2 pi is usually a good place to start. And the theta step, which we'll talk about here in just a minute, mine is at 0.017. That's just what it was set at. And I want to set my window here. And it's not necessarily a bad idea to start with your standard zoom window of a 10 by 10. So x min, negative 10, x max, positive 10. Y min about negative 10, Y max 10. And then we'll press graph and we'll look at it. Now it's not really zoomed square because of how small I got the screen, but I go to look at it and it makes one of those rose curves, which is pretty neat. Now I want to talk briefly about the theta step and the effect it has on the graph. So let me go back to this window here. Now my theta step was pretty small. And what the theta step does is it tells the calculator, well, once you plot one value on this curve, how far do you want the calculator to go before it plots another point, and then it tries to connect them. And the theta step 0.017 is pretty small. But let's exaggerate this theta step for a minute. Let's make it big. Like, so if my theta step was 1 in context of this range, this domain interval for theta that goes from 0 to about 6.2. So I'm roughly only going to get 6 points for the calculator to plot on this graph and see what the effect if it's still smooth or not. So my theta step being 1, and I look, and it's very jagged. It doesn't even look like a rose curve anymore. And so it was only able to plot about probably 6 points to work its way around and try to connect the dots, and notice the effect it had on the shape. Well, even if I made it like 0.5, where it would make 12 data points now over to that interval, it's still very rigid and not very smooth. So the theta step has a pretty big effect on the appearance of the graph. So let me go back to the way it was. 0.0174, I think is what it said, and that brings it to be nice and smooth. Now, so this is what the graph should look like when we're all said and done. To get table values, what I can do is I can go to my table settings, so second window, and I look. My table start is at 0, just like the table that we have, and we look at our table on the left hand side, and the step size is pi over 12. So I'm going to type in pi over 12 and enter. Now on the actual TI-84, it has some other options down here below the change in the table size, where you could probably set it to ask for the independent variable, and it would actually make this process a lot easier. You just type in the theta numbers and it will tell you the R's. But I don't have that on this calculator here. But so once I got my Theta Step set, now I can go to my table. And I look, and for the left-hand column are my theta numbers. It gives me my R values that correspond to it. So what I'm going to do is I am going to go ahead and fill in my table accordingly. And I'm going to color code kind of by what quadrant to help me get going. Okay, so now we have this table made, and we're going to plot the points in our table on this polar grid. And as we plot them, we want to indicate the direction that this curve would be plotting itself in. Okay, so we have this first set of points here that I have color coded here with blue that goes from 0 to pi over 2. And notice how they kind of go all over the place, but we have the graph here to the right of us to help us plot these points. Polar curves are nice and smooth. And in fact, where I have the change in my radius going from positive to negative, when I start at that point, that 0, 4, and then I go to pi over 12, 2, all right, and I'm working here, then all of a sudden I jump to where I have negative radius, and I come way over here. That means I have to pass through the pole. All right, so I have to come and pass through the pole as I get to that next point, and I try my best to keep this curve to be as nice and smooth as possible. Now that we have these first set of points plotted, we actually want to indicate the direction of travel in which we had to plot them. So I'm going to put little arrows along the lines so that way we can see the direction of travel along this polar curve we're graphing. Okay, now let's go to the second set in purple. We'll plot them as well, and after we get those points plotted, we're going to indicate the direction for them as well. Now we'll go to the third set here in green and do the same thing. Plot the points, indicate the direction of travel. And then lastly, the fourth set right here in red to complete our curve. And so now we have completed the graph of this polar rose with its 8 petals. Okay, so let's look at graphing another polar curve here. And this time, notice how the polar grid is in degrees. So when I go into my calculator to try to create this table of values for me, I need to make sure it's in the right mode. So I press mode, I confirm that it's in polar, and this time I have to make sure I change it over to degree for my angle. And I go press y equals, and I type in the polar function here. And we want to look and see, all right, well, what are we in for in terms of graphing? So if I press graph and I look at this shape here, all right, and so I'm looking and I have an idea as to what this is going to be. Now I want to fill in my table of values. So what I'm going to do is I'm going to go to my table settings. Actually, I want to check my window. If your graph didn't look like that when you graphed it, let's check what our window is. Our theta min needs to go from 0 and our theta max needs to go to 360 because we're in degrees. So that way we can see all the way around. If yours was 6 point something, your table settings transferred over from radians and you need to change that theta max. And everything else is pretty standard from there. Now I'm going to go to table settings so that way I can fill in this table. I want my table start to start at 0 like ours does. And our gap in our theta values here is 15 degrees. So my change in my table is going to be 15. And then we can go to table and we're going to copy all of these table values down. And then after we get the table filled in, we're going to graph them. All right, now that we have our table filled out, I'm going to work my way through kind of my color-coded areas, and we're going to start graphing them and making sure not only do we plot the points, but we indicate direction as well. And now we have completed the graph of this polar curve.